Hello and welcome to a video on prime factorisation. Now you may be a bit confused because you are seeing some chemical compounds on the screen here, and no, this is not a chemistry lesson, this is a maths lesson. But the reason I've got these pictures of chemical compounds on the screen here is because there are a lot of similarities between breaking chemical compounds down into their individual atoms and breaking numbers down into their prime factors. So before we get started, let's just go through what these chemical compounds are. So this first one here, we've got 1 atom of nitrogen and 3 atoms of hydrogen. So we can write that as NH3. And this is also more commonly known as ammonia. This one down here, we've got 1 atom of carbon and 4 atoms of hydrogen. So we can write that as CH4. And this is 1 molecule of methane. And these two here, you should be very familiar with these two. We've got CO2, which is also known as carbon dioxide. And this last one here is water, H2O. Now you may be wondering, what was the point in all of this? Well, just like chemical compounds, which can be broken down into their individual atoms, whole numbers can also be broken down into prime numbers. So apart from the number 1, every single whole number can be broken down into its prime factors. So let me go through some examples, because I think examples can be a lot more meaningful than just going through concepts. So if we start with 2, well, 2 cannot be broken down anymore. 2 is a prime number. So just like these individual atoms can't be broken down, because if they are, then they're no longer atoms, 2 also cannot be broken down any further. 3 also can't be broken down anymore. 3 is also a prime number. But when we get on to 4, well, 4 can be broken down. 4 is the same as 2 times 2. So you can think about these 2's being individual atoms, and they both combine to make up our chemical compound, in this case, which is 4. We move on to 5. Well, 5 is a prime number. 6, just like 4, 6 can be broken down. 6 is the same as 2 times 3. 7 is prime. 8, well, 8 can be written as 2 times 2 times 2. 9 can be rewritten as 3 times 3, and both of these are prime numbers. 10 can be written as 2 times 5. 11, well, 11 we can't break that down any further, that is a prime number. 12, well, 12 is the same as 4 times 3, but notice with here we can actually break down 4 even further. 4 is not a prime number, so we can write 4 as 2 times 2, so this is the same as 2 times 2 times 3. And now all of these numbers that make up 12 are prime numbers. Now if we move on to 13, well, 13 is prime already. 14 is the same as 2 times 7, and both of these are prime, so we can't break that down any further. 15, well, 15 is 3 times 5, and I think I'm just going to go up to 20. Hopefully you're getting the picture now. 16, well, 16 is the same as 4 times 4, but again, we can break both of these 4's down even further. So this 4 we can break down into 2 times 2. We can also break that 4 down into 2 times 2. So we've got 2 times 2 times 2 times 2, which is 16. And now all of my factors are prime. Now let's move on to 17. Well, 17 is prime. 18, or 18 is the same as 9 times 2. And just like before, we can break down 9. We've already said that 9 is 3 times 3. So we can write this as 3 times 3 times 2. 19 is prime. And finally, 20 we can rewrite as 5 times 4. But again, 4 we can break down into 2 times 2. So we can write this as 5 times 2 times 2. Now, hopefully you can see the resemblance between chemical compounds and whole numbers. So just like chemical compounds can be broken down into their individual atoms, like over here, all of these whole numbers can also be broken down into their prime factors. Now we stopped at 20, but in fact if we carried on, every single number after 20, every whole number can also be broken down into its prime factors. And that is what we mean by prime factorisation. So now it's time for you to have a go at doing some yourself. So what I'd like you to do is, there are 8 numbers here, 8 whole numbers, and I'd like you to break them down into the product of their prime factors. So just like we did before, I'm going to break each of these numbers down so that the factors are all prime numbers. Okay, so if we start with the first one, well, 30 is the same as 6 times 5. But we haven't quite finished because 6 is not a prime number. So we can break down 6 into 2 times 3. So this is going to be 2 times 3 times 5. 100, well 100 is the same as 10 times 10. So 100 is 10 times 10, but both of these are not prime numbers. So 10 is the same as 2 times 5. We can rewrite this as 2 times 5 times 2 times 5. And the order doesn't really matter, but it's nice to put them in numerical order. So we can just rewrite this as 2 times 2 times 5 times 5. Well, 27 is 9 times 3. And 9 is not a prime number, so we can break 9 down into 3 times 3. It's going to be 3 times 3 times 3. And we can also write this as 3 cubed, but I'm just going to leave it like this for now. 42 is 7 times 6. And 7 is prime, but 6 is not prime. So we can break down 6 into 3 times 2. And again, let's put this in order. So I'm going to put the smallest number first. So it's going to be 2 times 3 times 7. 80 can be broken down into 10 times 8. 10 times 8. And both of these numbers are not prime. So 10 is the same as 2 times 5. And 8 is the same as 4 times 2. And again, we haven't quite finished because 4 is not prime. So we've got 2 times 5 times 4. Well, 4 is the same as 2 times 2. So it's going to be 2 times 2. And then we've got that extra 2 at the end here. And again, if we just put this in order, we've got 1, 2, 3, 4 2s and 1 5. So 2 times 2 times 2 times 2 times 5. Okay, 108. Well, I know that 108 is in my 12 times tables. It's 12 times 9. It's going to be 12 times 9. And both of these can be broken down further. So 12 is 4 times 3. So 4 times 3. And 9 is 3 times 3. 3 times 3. And 4 again can be broken down into 2 times 2. So that's going to be 2 times 2. And then we've got all of these 3's. Times 3 times 3 times 3. Okay, 500. Well, 500 is the same as 100 times 5. Well, I can already see, I already know what 100 is. I've broken down 100 already. So 100 is 2 times 2 times 5 times 5. So 2 times 2 times 5 times 5. And then we've just got that extra 5 at the end there. And the last one, 9,000. Well, 9,000 is 9 times 1,000. 9 can be broken down into 3 times 3. And 1,000 can be broken down into 100 times 10. 100 times 10 is 1,000. So let's carry on. So we've got 3 times 3 times, well, 100 is 2 times 2 times 5 times 5. 2 times 2 times 5 times 5. And 10 is 2 times 5. There's lots of 2's and 5's there. And if we just put this in numerical order, we've got 1, 2, 3 2's. So 2 times 2 times 2. We've got 2 3's. 3 times 3. And we've got 1, 2, 3 5's. So 5 times 5 times 5. So let me just circle all of the answers just to make it clear. So notice how each of these numbers I've broken down into prime factors. All of these numbers that make up our whole number are prime numbers. So hopefully that video was useful, and in the next video we're just going to do the same thing, but this time instead of writing them out like a long list here, we can actually simplify this slightly using something called index notation. I'll see you in the next video.